Okay, this is 5.4. Alright, let's try the A again. 5.4a in college trigonometry, and now we're going to do the sum and difference identities of sine and tangent. We did cosine in 5.3, and now we're going to do tangent and sine in 5.4. So rather than go through all of the proofs in order of for how they found their answers, let's go ahead and go to example 1, and they're asking us to find the exact value of the sine of 75. So if you take your calculator and you put in the sine of 75, it's going to give you an estimate. It's going to give you a decimal that is going to go on forever and ever. So that's not what we're looking for as far as an estimate, because you get 0.965925826, da 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 da, goes on forever. So don't use that. But what we're going to do, we're going to use the table we have up there in the top left, and we are going to find two numbers added together or subtracted that give us 75 that we can find the sine of very quickly. And that's going to be the sine of 45 plus 30. And that will give us the sine of 75. So then we go to our plus part right here and rewrite this as the sine of the first one, cosine of the second one, plus cosine of the first one, sine of the second one. Probably my biggest mistake in this is I get the first and the second one mixed up. So I think I've got everything right there. Sine of 45, square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Plus cosine of 45, square root of 2 over 2. So don't put these in your calculator. Cosine of 45 is not going to give you the square root of 2 over 2. Now the sine of 30 will give you 0.5, and that's okay. But whenever you have these square roots, you can't do that. So remember, we did some things with special angles. So your special angles are a 45 and a 30, 60, 90. This is 1, this is 1, this is square root of 2. So if you're taking the sine of 45, opposite over hypotenuse, which is going to give you square root of 2 over 2. Okay, should be able to do that without any problem. Alright, so when we have our other angle, a 30, 60, 90, we know that this is 30, and this is 60. Make that 30 look like a 30. And this will be 1, 2, square root of 3. So, that being the case, then our cosine of 30 will be adjacent over hypotenuse. Our cosine of 60, if we were doing that, is going to be adjacent over hypotenuse. Our sine of 30 is going to be opposite over hypotenuse, and our sine of 60 is also going to be opposite over hypotenuse. So you can just make your triangle there at the top of your page and just put those numbers there. 1, 1, square root of 2, 1, 2, square root of 3, and then you've got them there to look at real quick and easily when you're trying to solve these problems here. So let's see what we've got here. I have sine of 45, cosine of 30, cosine of 45, and the sine of 30. Multiply through. Square root of 6 plus square root of 2. Can't add those. And I end up with that. Alright, so let's do B. Tangent of 7 pi over 12. Alright, so tangent of 7 pi over 12. Now for me, the easiest way to do this is to find out what 7 pi over 12 is in degrees, and then switch back to radians in a minute. But 7 pi over 12 is going to be 12 goes into 180, I think 15 times. Let's see, 15 times. So 15 times 7 will give me my angle. So that's going to be a 105 degree angle. Okay, you learn these little tricks as far as what 7 pi over 12 is. Alright, so it's a 105 degree angle. If that's the case, I need to find two angles added together to get me 105 that I know pretty well. So 45 plus 60 is going to give me a 105 degree angle. So actually, the tangent of 105 is going to be the same as the tangent of 45 plus 60, because that gives me 105. Alright, so now I have to change my 45 and 60 back to radians so that I'm matching that. So 45 degree angle in radians is, well, 180 degrees is pi. 90 degrees is going to be half of pi, so pi over 2. And half of that is 45, so that's going to be pi over 4. And 60 is a third of a pi, or a third of 180, so that's pi over 3. Alright, so that's the quick and easy way for me to switch back and forth from radians. You could have multiplied by the conversion that you learned earlier, but I don't remember where that is, and it's just easier to do it in my head like that. Alright, so now these two equal each other. So now I'm going to go, and I've got a tangent here, so I'm going to go over here to this one and rewrite it out so that it looks like that. So tangent of pi over 4 plus pi over 3 is going to be the tangent of my first one plus tangent of my second one over 1 minus tangent of my first one tangent of my second one right there. Okay, so it looks a little messy, but it's really not too bad. Because now what we're going to do is we're going to look and see tangent of pi over 4, or the tangent of a 45 degree angle. And if you have that handy dandy little triangle, you know that the tangent of a 45 degree angle is going to be opposite over adjacent, which if I look at my triangle that I drew over there, my tangent of pi over 4 is going to be 1. Tangent of pi over 3, and so I'm going to draw this one, and that's 1, 2, square root of 3. Tangent of 3 is a 60 degree angle, so it's that one, and the tangent is opposite over adjacent, so that's just going to be the square root of 3, because the square root of 3 over 1. And then I've got 1 minus the tangent of pi over 3, which I just said is square root of 3, times the tangent of pi over 4, which is going to be 1. I guess I switched these two around, doesn't really matter. So that gives me square root of 3 plus 1. I'm going to switch those around so everything looks the same. And I get that. Alright, so if you remember, the problem with that is that we have a radical on the bottom. You can't have that radical on the bottom. So even though that's our answer, we have quite a mess there that we still have to fix. So let's get rid of all this junk here so we can move things around. Okay, so that's our answer. So do you remember conjugates? Conjugates mean that we take the bottom number and we multiply the top and bottom by, everything stays the same, we just change the sign to its opposite. So this changes to 1 minus 3 on the bottom, and when we multiply those together, we end up with square root of 3, I'm just doing the FOIL method, and then combine like terms. So when I combine the square root of 3 and the square root of 3, I get 2 square root of 3. And when I add those, I get 4 over, and I had right here negative 2. Alright, so that looks good too, except I can factor some things out of here. and then cancel that with that. The negative is still there, so I get negative 2 minus the square root of 3. Because there was this negative, we just move up to the top, and everything in there, when we take the parentheses off, everything inside the parenthesis changes sign. So this 2 changes to a negative, this plus changes to a negative, and there is our final answer for B. Alright, let's look at C. Okay, so like on one of the other ones, we're going to kind of go backwards here. We're going to give you sine of 40 cosine of 60. So let's see how, or 160. Sine of 40 cosine of 160 minus cosine of 40 sine of 160. Alright, so which one is that? It looks like this one right here, doesn't it? Alright, so that will equal this part right here, the sine of A, which is going to be 40, minus the B part of it, which is the 160. So that ends up being sine of A minus the B. So when we take this, that's what this is right here. And we got it from this here. So we have the sine of negative 120. And remember from one of the negative angle identity, one of the earlier lessons, I don't remember which one it is, if you have a negative there, you can just bring it out to the outside there. And it's going to be that, because remember that negative angle, this negative angle here, all that means is we start here and go around 120 degrees. And that's the negative 120 degrees. That's the only difference. So it's just like going 120 degrees this way and then putting a negative sign on it, which is what we did here. Alright, so let's look at one more example and we'll be done. Okay, so it says suppose A and B are angles in standard position with the sine of A being equal to 4/5 and cosine of B equal 9 or negative 5/13. Okay, and then they give us some other stuff here. Let's see what it says. They say that that pi over 2 is less than A, which is less than pi. Alright, pi over 2 is less than A, which is less than pi, tells me that this angle right here is between 90 and 180. So that means it's in the second quadrant here. So let's get rid of that. That's all that tells me, is that I'm in the second quadrant. And then I can go from here, and it tells me that my sine of A is 4/5. So this is A. It's 4/5. Opposite is 4. Hypotenuse is 5, which tells me this is 3. Remember the 3, 4, 5 angle. Alright, let's look at the other one, cosine of B. What does it say about the cosine of B? It says that pi is less than B, which is less than 3 pi over 2. So 90 and 270. So B is in the third quadrant between 180 and 270. So I'll put that there and label what we can here. Cosine of B is adjacent over hypotenuse. So my adjacent is negative 5 and my hypotenuse is 13. And then I have to find my opposite side here, and that ends up being 12, I think. I think that was the same as it was in the last problem. Alright, so we got all that information. They want us to find each of the following. First thing they want us to do is find the sine of A plus B. Alright. So what do we need to solve this? Let's pick a yellow here and kind of write this down. We need to know, we've got the sine of A and we've got the cosine of B, so we need the cosine of A and we need the sine of B, because this sine of A plus B is the sine of A cosine B plus cosine of A sine of B, and that's just taken from right there. So I've got the cosine of b and the sine of a, so I just need to find those two. Alright, so the cosine of a is adjacent over hypotenuse, and if I look up here at a, my adjacent is going to be, oh, that's going to be a negative, isn't it? A negative 3 there. Don't want to make the same mistake I did earlier. Negative 3 over 5. Now there's a long drawn out way the book does it, but I don't know. I don't know why they do it that way when it's a lot simpler to do it this way. Sine of b then, we're looking down here at this one, is going to be opposite over hypotenuse. My opposite, now that's a negative 12. Negative 12 over 13. Alright, so that gives me my sine of b. So I have everything. Now what I'm going to do is I'm going to rewrite all of this with, instead of the sine of a, I'm going to put in 4/5. Instead of the cosine of b, I'm going to put in negative 5/13. So I'm going to get all the numbers on here. And let's do this in kind of a pinkish purple here just to kind of make it different. So we've got sine of a is 4/5. Cosine of b, negative 5 over 13. Cosine of a is negative 3/5. Sine of b is negative 12 over 13. So you're just going to multiply those together, add everything up, and you're good to go. And I'm not going to do the b part tangent of the quantity a plus b. It's done the exact same way. The only difference is you're going to be using this formula right here. So you're going to have to find the tangent of a and the tangent of b. And you know your a and b were, sine of a was 4/5. The cosine of b was negative 5/13, and then you're able to find your tangent just by using these, because you've got opposite over adjacent instead of opposite over hypotenuse or adjacent over hypotenuse. So your tangent of b here is going to be negative 12 over negative 5, which is 12/5, and your tangent here is going to be opposite over adjacent, so negative 4/3. So you're going to use those numbers instead, but other than that, you're just going to use this formula up here and go ahead and solve it from there, and we won't worry about C. And brings us down to example 4, and then we'll be done. Okay, so this one is using your verifying skills, and what we're doing is we're saying if we take this angle, this 30-degree angle, and add an angle to it, call it angle S, and we take the sine of it. We do the same thing. We take a 60-degree angle and add S to it and take the cosine of it. Add them up, we're going to get the cosine of that angle here. Okay, so we're going to take the left side and simplify it and ignore the right side right now. Alright, so I know the sine of theta, or pi over 6 plus s, we're going to use this formula right there. So we're going to rewrite this in this form, and then this in the other form where, you know, because this is the sine of a plus b and a minus b. There's, remember, back in the beginning of this lesson we had one for cosine, so we'll go back and write that in just a minute. So let's go ahead and take the sine of pi over 6 and write that out. So that's going to be sine pi over 6 cosine of s plus cosine of pi over 6 sine of s, plus, and then we're going to do this one. We're going to go back to the table and do that. And that table says cosine of pi over 3 cosine of s minus sine pi over 3 sine of s. Okay, so this whole thing matches up with the table for that. This whole thing matches up for the table for that. Alright, so let's go ahead and see what we've got here. Sine of pi over 6, that's a 30-degree angle, so that's 1/2. Cosine of pi over 6, which is again a 30-degree angle, the cosine of that is the square root of 3 over 2. sine of s plus the cosine of pi over 3 is 1/2. That's cosine of 60. Cosine of s minus the sine of pi over 3, which is going to be square root of 3 over 2 sine of s. Okay, so we've kind of brought this down a little bit. One of the things that you might want to notice here, like terms, opposite signs. So these will go away. And then we have 1/2 cosine of s plus 1/2 cosine of s, which is 1 cosine of s, which matches what we have right there. So that's how we verified that.